Alright, welcome. In this video, we're going to start our pre-calculus course with a little discussion of functions and equations. And like it says on your notes, two of the main themes of AP pre-calculus are going to be analyzing functions and using functions to model scenarios. And today we're just going to start with basics, right? What do we already know about functions? And so, hopefully in an earlier math class, you talked about some functions and you saw that it was a mathematical relationship that kind of took in a number, gave you back a number. Okay. And, fine print details are that, each input value is going to give us exactly one output value. And we'll start with a function that we're somewhat familiar with, maybe. F of x equals x squared minus 4. So it asked us to make a table and sketch a graph. Okay. And what this is doing is it's forcing us to look at this function from two different perspectives. And in this course, we'll be very interested in looking at various functions from different perspectives, mainly the algebraic, graphical, and numeric perspective, but also sometimes the verbal perspective. We're interested in a variety of perspectives in AP Pre-Cal. So we'll start with the graph. Well, you remember, y equals x squared makes parabola. Okay, and x squared minus 4 would be a parabola that kind of got moved down by 4. Or has a y-intercept of negative 4. So maybe I'll start with the parabola. Oh, that looks good enough. And we can put some axes in, and that's just going to be a good enough sketch for us. And that would be a sketch of the graph. For a table, I just chose x being 0, 1, 2, and 3. The point here is that, if we're trying to figure out what value of f corresponds with the x value of 0, we're going to go in and we're going to plug in x equals 0 wherever we see x in the formula for f. So if we're interested in finding the value of f of 0, we just replace x with 0 wherever we saw it in the formula. So that would be 0 squared minus 4, and that would be negative 4. And if we wanted to figure out what f of 1 is, we do the same thing. Let's say f of 1 is 1 squared minus 4, and that feels like negative 3. And then we could do the same thing for 2 and 3. And we would see that f would produce values of 0 and 5 with input values of 2 and 3. And those input values, those x values, we're going to call that the independent variable, kind of like we did in previous classes. And the output variables, the things we got back, f, so we call that y, and that'll be our dependent variable. And so in this situation, there wasn't really any input that we couldn't put into f. There wasn't any value of x that we couldn't square and then subtract 4. So I would just say, any real number. But if you think about, something like x squared minus 4, well, the very least that can be is going to be negative 4. And because, x squared is always a positive number, unless x is 0. And that would be the very minimum that x squared could be would be 0. And so the very minimum that f could be would be 0 minus 4. Also, you can see that on the graph because that was like the very bottom point of the graph was at y equals negative 4. So y representing the outputs. The outputs are going to be, let's say greater than or equal to negative 4 for any x, any real value of x. And so I'd say the outputs would be y greater than or equal to negative 4. And although it's something we're going to focus on more later in the class, I will tell you right now that the set of all possible input values for a function is what we're going to call the domain, and then the set of all actual output values, we'll call that the range, but that's maybe a discussion for a different day. Okay, so if we ask for the value of f of 0, we actually already found that, but I think it might be good for me to remind you. Okay, so if f of x is equal to x squared minus 4, and we want f of 0, what we're doing is, I can show you like with an eraser, we're just going to go in and replace x with 0. Okay? And so that's going to be equal to negative 4. And if we're asking what value of x makes f of x equal to 0, that's where we're solving an equation. Okay, we were given an equals, so then we have to solve for the value of x. And so we've got an expression for f of x, that was x squared minus 4. And we're interested in where that is equal to 0. And what we're going to do is we're just going to, at least for today, just do the same thing to both sides of the equation to try to solve at x. So I'm going to start by, getting rid of this negative 4. So I'm going to do the opposite. I'll add 4 to both sides. And then I'll take the square root of both sides of this equation. And, you might remember from algebra class that when you take the square root of both sides of an equation, we need to remember a plus minus. And so we've got plus or minus 2. But just telling you that you need to remember a plus minus, that's not how I like to operate. I prefer to remind you of why this is true. So I'm going to just jump off into some blank space and kind of remind you about that. All right, So if we're working with something like x squared minus 4 and we're taking the square root of both sides, what we're doing is the square root of x squared equals the square root of 4. And if you're in my algebra class, you probably heard me say more than once that the square root really means the positive square root, not plus or minus. Okay, so what this expression on the left is equivalent to is the absolute value of x. If you think about it, if you take a number and you square it, it's going to be positive, and you take the positive square root, that's going to be positive as well. But we could take a negative number, square it, and then take the square root and get the positive version back. So that's why this is equivalent to the absolute value of x is equal to positive 2, and that's where the plus or minus comes in. But absolute value equations, not really part of AP Pre-Cal, so it's not something I need you to worry about on a daily basis. It's just something I need to remind you about why we're under the plus or minus. What we did right there is equivalent to finding the x and the y-intercept on the graph of y equals f of x. And, the details of this is exactly what we're going to get into in this pre-calculus course. But for now, I'd like to just kind of remind you that a y-intercept on the graph of a function, to say it went through that point, like that, it's going to be a place where x is equal to 0. And then an x-intercept on the graph of a function, where we intersect the x-axis, it's going to be a place where y is equal to 0, right? And, equivalently, if you're asked to find the y-intercept, what you're going to think to yourself is, find the value of f of 0. And for an x-intercept, you're going to solve the equation f of x is equal to 0. And that's something that we're going to do regularly in this class. So if we're confronted with a function like g of x equals negative 2/3 of x minus 6, and they ask us to find the x and y intercepts on the graph, we're going to find g of 0, and we're going to find the solutions to the equation g of x equals 0. So let me set that up for you. So we're going to find g of 0 to get the y-intercept. We're going to say, all right, well, g of 0, I'm going to replace x with 0 wherever I see it in the formula. Negative 2/3 of 0 minus 6. And that's going to be negative 2/3 times negative 6. So that'd be like positive 12 over 3, and that's going to be 4. And if I need to find the coordinates, which it didn't ask for, but sometimes it asks, like, what's the coordinates of the y-intercept? It's the point where x is 0 and y is 4. And for the x-intercept, that's where we're going to solve the equation. So I'm going to go over here, and I'm going to say I've got a formula for g of x. That's negative 2/3 of x minus 6 equal to 0. And at this point, you've got a couple of options. You could distribute the negative 2/3 over the x and the negative 6, or you could just divide both sides by negative 2/3, and it's really however you want. You could use the zero product property. Say if two things are multiplying together at 0, one of them is equal to 0, and it's not negative 2/3, so it must be x minus 6. Either way, you're going to see that the solution to this equation is going to be x equals 6. And so that'll be my x-intercept. If you're asked for the coordinates of the x-intercept, it would be where x is 6 and y equals 0. Now for these other ones, find the value of g of 15 and, g of x equals 15. So this is something you can try on your own, right? See what happens when you plug in 15 for x to find the value of g of 15, and see what kind of x you get back when you solve the equation g of x equals 15. You should definitely pause the video right now though, because I'm just going to bring in the answers here in about 5 seconds. So go for it now. Pause now. All right, there you go. So I am seeing g of 15 equaling negative 6. I plug in 15 wherever I saw x in the formula, did some arithmetic, got that. But on the right, we had to solve an equation, and I think this is probably a good time to bring up this somewhat important point that, I did some steps in here, and I am assuming that coming into this AP Pre-Calculus class that you do have a little bit of algebra skills. Okay. Now, if you aren't following all the steps I did here, that does not mean that you're not ready for AP Pre-Cal. We really think that this course is something that pretty much anyone that has passed Algebra 2 of any level can achieve. If you're having any trouble with these steps, though, that's what you need to come talk to me about and work with me on, so I can help get you confident enough that you think that you can solve any of these equations, because I know you can. It's just going to be an issue of practice. And so on this one, I did kind of some different steps. I multiplied both sides by 3, then divided by didn't divide by negative 2. I distributed the negative 2. But, you could go whichever way you want. And if you got negative 33 over 2, then good for you. You were heading in the right direction. Yes, then this question I forgot about down below. Sketch the graph of y equals g of x on the xy plane. So we say the xy plane, that's just the standard axes we're used to graphing on. And okay, well, we know the graph of this thing is just going to be a straight line, okay, because it's just a first power of x. And we've got an x-intercept and a y-intercept, so why don't we just go ahead and plot that? The y-intercept was 4, maybe that's going to be right here. X-intercept is going to be 6, maybe it's a little farther out. And, well, 2 points uniquely define a line, so I can just go in and connect those dots. Hopefully it goes pretty well for me. Looks good to me. I think that's going to be a sketch of the graph. Plenty good for us. All right, now I need to talk to you about some special exponents that you hopefully learned about in Algebra 2. I'm going to start first with the zero exponent. And it seemed like on the first day of school when I was delivering this lesson, a lot of the students in my class remember the special trivia fact from algebra that x to the 0 was going to equal 1. And well, that's good. I think I'm going to need you to know that at some point in this course. But this is a very new course to us, right? Nobody's ever taught AP Precalculus before this year. We're teaching for the first year. And so I don't really know exactly what we are going to need and not need over the course of the year, but I think it's pretty safe that we're going to need possibly zero exponents, negative exponents, and fraction exponents, or at least be able to reason with them. So x to the 0 is 1, and the reason that I was given in class for that is, kind of think about like x to the 6 divided by x to the 4. If I divide that, I'm going to have 6 copies of x on top and 4 on bottom. And if I cancel them off, I'd have net 2 on top. So what I was doing is I'm subtracting 6 minus 4. But if I have x to the 3 over x to the 3, well, you know that's 1 because you take something and you divide it by itself, and that's 1. Same idea. That's x to the 3 minus 3 is 0. And that's going to equal 1. And so that's why anything to the 0 power is 1. I will point out that 0 to the 0 is not going to be 1 because that's equivalent to 0 divided by 0, and that's not defined. So we'll talk about that more later in the course. For negative exponents, I think the key fact that you need to know is that x to the negative 1 is equal to 1 over x. And kind of for the same reason I was talking about over there, the kind of the net difference, you had x to the 4 divided by x to the 5 on bottom. You'd have net 1 more on bottom, and if you did 4 minus 5, that would be a negative 1 exponent. Okay, but x to the negative 4, that's going to equal 1 over x to the 4, and I think maybe I'll remind you of one way of thinking about why that's true. You could go over here and you could say x to the negative 4 is x to the negative 1, or actually, somebody in class pointed out to me it would be smarter for me to propose it as x to the 4 to the negative first power, right? Because this is a situation where we would multiply the exponents right there if we're taking power of a power. So if we do that, we know it's the same, that's x to the negative 4, but we also know that the negative 1 exponent turns something into a fraction, or if it's already a fraction, it flips it. And so that's where I get 1 over x to the 4. And then for fraction exponents, and you need to know about those too, x to the 1/2 power, that's equivalent to the square root of x. And that's one that's a little more easily forgotten about, I think. And then x to the 2/3, when we've got like a numerator and a denominator, what we have to do is kind of think about them separately. So x to the 1/3 power would be the cube root of x. And I always recommend dealing with the denominator first for reasons that I think will become apparent down like when I get into the examples. So I'm going to say this is the cube root of x, but I've still got that 2 on top. So I'm going to say it's squared, right? Because this is like x to the 1/3 squared. And we multiply the exponents just like we did before. Okay, so these are just kind of some key facts that we're going to need to maybe work off of for these examples below. So what we're seeing the first one is if h of x equals 4 to the x, okay, so that's an exponential function, and we will talk a lot about exponential functions in this class, but not for a couple of months. This is really just like the only way I could think to force us to run through some fraction exponent, negative exponent situations. And that says to find the value of h of negative 2, h of 0.5, and h of 1.5. Okay, so let's just start with h of negative 2. So h of negative 2, wherever we see x in the formula for h, we're going to replace it with negative 2. So that'll be equal to 4 to the negative 2 power. And we saw up above, x to the negative 4th power was 1 over x to the 4. So 4 to the negative 2 is going to be 1 over 4 to the 2 power. Remember, a negative exponent doesn't make the number negative, it just turns it into a fraction. Okay, so it's 1 over 4 to the 2, and in AP Pre-Cal, we are going to be called to simplify our answer. So we're going to need to write that as 1 over 16. Okay, when it comes time to do h of 0.5, okay, that's equal to 4 to the 0.5 power, but I don't know about you, I'm not very good at taking numbers to a decimal power. That's not in my skill set. That's not something I showed you about up higher on the page. So let's just translate that to a fraction. We know that 0.5 is the same as a half. So 4 to the 1/2 is the square root of 4, and that's going to equal positive 2. Okay, this is another reason why the square root means the positive square root. If you pulled out like a graphing calculator, or opened up a new browser tab and went to desmos.com and graphed y equals 4 to the x, and you looked at where x was 0.5 or x was a half, you'd only see graph up there at positive 2. It's not plus or minus 2. Okay, so that's just even more evidence to why the square root, it means the positive square root of a number. As far as what value of x could make h of x equal to 1 or 0, okay, well, h of x equals 1, that would be 4 to the x equaling 1, and I think this is the type of equation we're actually best equipped to solve with our eyes rather than trying to do the same thing to both sides. If you remember about logarithms from last year, like, good for you. That's great. If you don't, that's not a problem either. That's not one of our assumed prerequisite skills, and I will work with you on the logs in, I'd say, about 2 months. 4 to the x equals 1, we're just thinking, okay, well, what x would I put in there? Anything to the 0 power is 1, so that's going to be x equals 0. Oh, whoops. 4 to the x equals 1, no, it's n. Okay, x equals 0. But if we wanted to make 4 to the x equal to 0, okay, that's going to be harder to do, and I'm just going to say that's not going to be possible. Because, 4 to the x is like repeated multiplication by 4, maybe repeated division by 4, repeated some kind of root of 4. This is not possible. And definitely not possible for any real value of x, because, you multiply by 4, you divide by 4, you're going to have a number that's not 0. Okay? The only way we could get 0 in terms of multiplication is by starting with a 0. Okay, so I think that's all I got to say about that. And I forgot I had put this disclaimer in just on the next page. It's like, we won't be interested in exponential functions until later in the course, but we will need to evaluate expressions like 8 to the 2/3 and 5 to the negative 2, at least to solve problems in this lesson, but overall in this unit and in this course. So if we've got capital F of x equals 2x to the 3 minus 5, and we're asked to evaluate f of negative 3, just like before, we're going to plug in negative 3 wherever we see x. So we'll be taking 2 times negative 3 to the 3rd power minus 5. In this situation, we got all numbers, so we need to, observe our order of operations respectfully. And so we're going to take negative 3 to the 3rd power first, because exponents before multiplication, right? PEMDAS. So negative 3 to the 3rd power is going to be, well, 3 to the 3rd would be 27. If it's negative to an odd power, it'll still be negative. So 2 times negative 27 minus 5 more. So that would be, I think, negative 54 minus 5, and that's going to be negative 59. And then solve the equation f of x equals negative 21. Okay, let's set that up. We're going to just kind of do the same thing to both sides of the equation until we can access x on its own. So we're going to go, and I think, kind of go in reverse order of operations, what I would recommend. So deal with that addition and subtraction first. We've got that subtraction of 5, so we need to get rid of that. We'll do the opposite. That's going to be add 5 to both sides. So 2x to the 3 equals negative 21 plus 5 is equal to negative 16. And then I'd divide both sides by 2. So I'd get x to the 3rd equals negative 8. And then I could take the cube root of both sides. That's what I'm going to need to do to get rid of that 3rd power and take the 3rd root. And so I'll take the cube root of x to the 3, and that's going to just be x. And I'd have the cube root of negative 8. And when I take the cube root of both sides of an equation, unlike before when I was talking about take the square root of both sides of an equation and incurs a plus minus, this will not bring in a plus minus. Really, it's because the cube root of a number is unique, but I'm not going to get into that right now. I'm already kind of close to 20 minutes, so I try to keep these two, but first day, there's a lot of facts I needed to get through and examples and getting you warmed back up so we can shake off the rust and get to it with this pre-calc course. Then another thing I want to remind you is that the cube root of a negative number is perfectly fine to take, and cube root of negative 8, negative 2, right? Because if I take negative 2 to the 3rd power, I get negative 8. Okay, now question. Do you remember what the graph of y equals f of x looks like? If so, good for you. If not, no big deal, right? We'll talk about the graphs of these polynomial functions extensively over the next month or so, and so yeah, I don't think I actually got to this in the lesson on the first day because we weren't working with as much time as I expected. But if you remember, try to give it a sketch right now, and if not, maybe pause the video and go look at Desmos. But I'm just going to copy it in real quick and show you what it looks like. All right, there you go. So that's my sketch of the graph of f of x equals 2x to the 3 minus 5. Okay, it's kind of a cubic looking graph. if you remember what that looks like, and if not, no big deal, that's not any reason to not take the course. And then it got shifted down by 5, and it was twice as tall as usual, but that's not a big deal, and we'll work on all that stuff throughout the course, and I'll show you how to come with that on your own. Something we can do today is find the coordinates of the x-intercept and the y-intercept. So what's the y-intercept on the graph of h? Oh, I can see it, it's right there, it's at -5. But you could also say that h of 0 was equal to 2 times 0 to the third minus 5, and that was equal to -5, right? And then as far as the x-intercept goes right here, that's something where we're going to have to solve the equation h of x equals 0. Okay, so that's going to be, I always like to write that first, so that's going to be 2x to the third minus 5 equals 0, and then we will solve this one like we did before by doing the same thing to both sides of the equation. Let's see, let's zoom in on this. So we're going to start by adding 5, dividing by 2, and then taking the cube root of both sides. And like, yes, this is not going to have a rationalized denominator, and I know that that's probably something we're supposed to do in AP Pre-Cal, but I'm pretty sure they're not going to have you rationalize the denominator of a number like the cube root of 5 halves. I just don't foresee that. So that's going to be the x-coordinate of my x-intercept, and that'll be, we solve for it, right? It's a number. It's there. It's positive. And that's pretty much confirming what we saw in our sketch. I don't really know what the cube root of 5 halves is. I doubt it's that big of a number. Definitely less than 5, right, based on my sketch of the graph. But you can see it's a positive number. That's good enough for us. All right, now we've got a function that is defined in terms of a negative exponent. So, depending on how you feel about it, maybe I'll just start find g of -3. G of -3 is going to equal 18 times -3 to the -2 power. And we could go and say, okay, well, the -2 power of something is going to be 1 over that thing squared. It doesn't make the number negative, it's just going to make the power negative, which means it's in the denominator of a fraction. So we're over here, -3 squared is 9, so that's 18 divided by 9, and that'll equal 2. And so I just fill in that table right there. Okay, but if you see what's really happening here is x to the -2 is like dividing by x squared. What we could do is we could go in and we could just rewrite g of x, and that would make it much easier to evaluate, at least in my opinion. So I might rewrite this as 18 over x to the 2 and kind of work with that. Okay. Now, if x equals 0, okay, I go and I try to find g of 0. And that's going to be 18 over 0 squared. That's not defined. Like I said earlier, we're not dividing by 0. Okay, that's not a defined operation. So I'm going to say DNE for does not exist. You can say undefined, maybe put a little empty set, probably a slight misnomer, but it's not a big deal. That's not what we're focused on in this pre-calculus course. And then over here, if I have g of x equals 24 in a blank slot in the table above it, I'm trying to solve what x gives me g of x equals 24. So I can go over here and I'll say, all right, 24, that's the value of g, and that's going to equal 18 over x squared. What I could do, I'm going to eventually want to find x, right? So that's going to be in a numerator. So I need to get this x squared out of the denominator. What we can do is we can multiply both sides by x squared. And I'll show it this time. Whoops. Okay. And then just multiply by x squared over here. Idea being I can cancel these off and I can say 18 equals 24 times x squared. But I want to get out x squared just to get at x. So I'm going to divide both sides by 24 and I'll have x squared equals 18 over 24. I see that 6 divides 18 and 24, or you can see maybe they're both even numbers and you can start reducing it that way. But I think that's going to be 6, 12, 18, 24, 3/4. And so then I'm going to take the square root of both sides, and that's going to be something I could, it would cause me to bring in a plus or minus. Plus or minus the square root of 3/4. And then I think this is the reason I put this on here, was I wanted you to see that we need to be able to rationalize the denominator to give our answers in AP Pre-Cal. So that's the square root of 3 divided by the square root of 4, and fortunately for us, we know what the square root of 4 is, and so it's going to be root 3 over 2. And believe it or not, this is a number that we're going to encounter quite a bit in this pre-calculus class, but for us, not until the second semester when we start to do trigonometry. So I'll just put in this plus or minus root 3 over 2, and I'll move on. This next example, I think I'm going to do the first thing because never told you what radical form means. I'll do that for you, but then I'm going to have you try the next two parts on your own because I'm trying to get you on out of here, start practicing soon. So we're going to start by writing h in radical form. Oh, whoops, pardon me. That wasn't the right pen. I'm going to say, okay, radical form is the form that involves a radical, like a root. So if we have got 3x to the 2/3, the 1/3 power, always I recommend doing the cube root first, or pardon me, the denominator first, and since that was the 1/3 power, that was a cube root. And then we'll square that minus 9. That's h of x, and that's what I would call radical form. Just write it, instead of having a fraction exponent, having some kind of root. And then you find the value of h of -8 and the values of x to make h of x equal to 18. And then you can check your work against mine, because I'm just going to bring them in 3 or 4 seconds. All right, there you go. So if I plug in x equals -8, I'm going to get an output of 3. And I think that's pretty straightforward. I think most of the students in my class are going to be fine with that. It's the second part that I know that there's going to be problems. Solving an equation that involves a fraction exponent. So knowing that, I just went back to the fraction exponent definition of this expression here and just kind of solved that way. Now, if you think it'd be more reliable going to I call this the radical form and solving that way, that's exactly what you should do. Okay, because in this class, provided that your answer is mathematically correct and justified, I'm going to credit you. And I don't need you to do it exactly the way I do. Okay, I don't want you to do it the way you see that makes sense to you. Provided it's like not illegal or invalid. So over here, I kind of try to isolate the x. Eventually I get x to the 2/3 equals 9, and I'm going to need to take both sides to an appropriate power. You want to take both sides to the reciprocal power, though, and so that's going to be the 3/2 power. I'm taking 9 to the 3/2. That's the square root of 9 because of the half. Taken to the 3rd power because of the 3/2. Square root of 9 is 3. 3 cubed is 27. Now, technically, I did take the square root of both sides of the equation right here in this step when I took both sides to the 3/2 power, right? Because the 3/2 is the square root cubed. So really there would be a plus or minus there. But what I'm saying is, especially at this point in the course, if you give me x equals 27, I'm going to be like, great work. You've solved for x. And, yes, there's another solution out there that's -27, but that's really not my focus at this point. If you want to find all the solutions and be like 100% correct, yeah, you're going to put a plus minus here. But I'm not so worried about that right now. All right, now the last two examples I got for you are examples I want to go through because they're going to be on the homework, they're going to be on the quiz, and they're going to be on the test, right? So I want you to be well prepared. So the first one is, suppose g of x equals 5/6x plus k, where k is some constant that we're going to find out using the data we're given. And so say if g of -12 equals 3, that's what we're going to use to find k first, what's the value of g of -2? Okay. So in red, I'm going to be finding k. So I'll say g of -12 equals 3. Well, on one hand, g of -12 is going to equal 5/6 times -12 plus k. But they also tell me that g of -12 equals 3, so maybe I'll just write it like this. G of -12 equals 3. Yeah, so 5 times -12/6, you could look at it, as 5 times -12 is -60, divided by 6 is -10, or you could divide the -12 by 6 first, which is what I would recommend, and then you're doing 5 times -2, and that's much less error prone, at least in my opinion. So I've got -10 plus k is equal to 3. Okay, well, I guess that's probably an abuse of the equals there. And this is the type of equation I'm going to recommend you try to solve with your eyes and say, okay, what number am I going to add to -10 to get 3? Well, I'd have to add 10 to get back to 0 and 3 more to get to 3, so that's going to be 13. But if you want to just be an algebra robot and add 10 to both sides, that's essentially what I did there, kind of like when I was reasoning through it. So I've got the value of k, so knowing that, I can actually say that g of x equals 5 divided by 6, x plus k, which is 13. And actually, maybe I'll just write that in red to really emphasize the point that I found that with the work up there using the initial condition they gave me. So they asked me what's the value of g of -2. And g of -2 is 5/6 times -2 plus 13. Okay, so 5 times -2 is -10 over... Actually, I'll probably just simplify this first, because -2/6, that can be simplified to -1/3. So I've got -5/3 plus 13. And if I'm going to combine these to get a one answer, which I need to have a simplified answer for AP Pre-Cal, I'm going to have to turn 13 into thirds, and 13 over 3 or 13 is equal to 39 over 3. So if I add these together, 39 minus 5, that's going to be 34 thirds. I guess the moral of this story is that we can't always expect in this class, we're not going to be able to expect that all of the solutions to all of the problems will be whole numbers, right? We might have fractions like this, we might have square roots. You can't be certain of what we're going to have. The last example I've got for us is a kind of an applied algebraic geometry problem, the type of which you are going to see, like I said before, on the homework, the quiz, and the test. So let's just familiarize ourselves with it right now. Okay, so they're talking about a rectangle, but they didn't draw us a picture, so we should probably draw our own. Okay, so length and width, whatever, I'll just say this is x minus 5 squared. This one's also going to be x minus 5 squared, and width 4. Maybe the width is that way. And the perimeter of this rectangle is equal to 26. So that means that 26 is what I would get if I added 4 to x minus 5 squared and another x minus 5 squared. And I'm pretty sure you're going to know how to add 4 to 4, but I kind of worry about this x plus 5 squared plus x minus 5 squared plus x minus 5 squared, because that's the type of thing I taught Algebra 2 last year. I don't think we ever added two things together like this. So, but if you think about x minus 5 squared as its own thing, like w or something, if you had a w plus a w, that's 2w. So what I'm going to say is this is 8 plus 2 of these x minus 5 squares. And now I'm just going to solve at x kind of the way I had before, just by isolating the parentheses squared and then taking the square root of both sides and solving for x. But first things first, the farthest thing away from the x is that 8, so I'm going to subtract the 8 from both sides. 26 minus 8, that's going to be 18, equals 2 times x minus 5 squared. And then I'm going to get rid of the 2 on the outside of the parentheses, and it's multiplied, so I need to divide it. It'll leave me with 9 equaling x minus 5 squared. And then I'll take the square root of both sides of this equation to get rid of that square. That'll bring in a plus minus. Right, so I'll say plus or minus the square root of 9 equals x minus 5. And I can solve for x by adding 5 to both sides. Yes, okay. So that would be, I've got two answers, 5 plus 3 and 5 minus 3. So x equals 8 and x equals 2. So to recap what we did today, really just kind of reviewed the idea of a function and just kind of toyed around with some concepts from Algebra 2. And we did start in on our essential knowledges for AP Precalculus, and I will try to, as much as possible, bring those in when we're hitting them in the notes, just so you know that from the AP Precalculus course description, we are doing exactly what they say. So you can have faith. I will teach you all the topics and leave you well prepared for all of the possible questions that they might ask on the AP exam. So yeah, we talked about a function and we talked about the input and output values of those functions. We're really just getting started today, but thanks for joining me. Thanks for signing up for the class. I'm really excited to work with you and possibly help you get credit for pre-cal through AP Precalculus. All right, so thanks for watching. Hope to see you next time.